A carpenter makes tables and chairs. Each table can be sold for profit of 30 ringgit and each chair for a profit of 10 ringgit. The carpenter can afford to spend up to 40 hours per week working, and it takes 6 hours to make a table and 3 hours to make a chair. Customer demand requires that he makes at least 3 times as many chairs as tables. Tables take up 4 times as much storage as chairs, and there is room for at most 4 tables each week. Now this is a linear programming problem. In this problem, we should identify what are the variables in the form of a whole number. So if you look at the words that I have bold, they are profit, working hours, number of chairs and tables, and storage space. Now, which of these is, or which of these are the variables that we want? Okay. What are the whole number variables involved? Okay, so in this problem you have to identify the variable. Okay, what are the variables involved? So you don't tell me it's the profit, because profit is 30 ringgit, 10 ringgit. They are known, they are not variables. And don't tell me they are working hours, because 40 hours, 6 hours, 3 hours, they are known. Okay, so what are the whole number variables involved? Okay, over here we have profit, working hours, storage space, number of tables and chairs. So of these 4 or 5 factors, what are the variables? What are the things that is changing that we need to find? So first of all, we need to identify the variables. Okay, yes, the variable here is the number of tables and number of chairs. And please take note that the number of table and number of chairs, they have to be whole numbers. Okay, you cannot have half a table or half a chair, right? Or 3.5 tables, 4.9 chairs, or 6.5 tables. You cannot have these things. Okay, so now we have identified the variable. The others, they are the factors in the problem. So the variables in this problem, they are number of chairs and number of tables. The others, profit, working hours, storage space, they are all factors that affect the problem. Okay. Okay. No battery here. My mouse got no battery. Okay. So sorry. Mouse got no battery. Okay, so we are going to the next page. Okay. Okay. Right. Okay. Right. Let the number of tables and chairs be X and Y respectively. Okay. So since we have identified the variables and we have to allocate symbols for each of the variable that we need to find. So let's say X is the number of tables and Y is the number of chairs. Okay. So the two variables here, they are X and Y. Now X and Y, they are number of chairs and number of tables. They are whole numbers or they are natural numbers. So the value of x must be greater or equal to 0. That means you must have at least 0 chairs, 1 chair, 2 chairs, 3 chairs, and so on. Similarly, the table also you need to have at least 0 table, 1 table, 2 tables, 3 tables, and so on. So that is why we arrive at this inequality. X must be greater than 0, y must be greater than 0. You cannot have negative chairs and negative tables. Okay, the next step, you have to construct a table. Construct a table involving the variables. So the tables, they are the table like this, the factor, number, profit, working hour, and storage space. For table, we have allocate the symbol X for the variable table and Y for the variable number of chairs. Okay, so here we are. Number of tables X, number of chairs Y, total number X plus Y. So X represent the number of tables. X can be 1, 2, 3, 4, 5. Yeah. So we can have 1 table, 2 tables, 3 tables, and so on. Y also represent the number of chairs. So Y can be 0, no chairs, 1 chair, 2 chairs, 3 chairs, and so on. We don't know what is the number, but we give it a symbol, a variable Y. Okay. The next factor is profit. The next profit. Okay. Now, one chair, one table, they make a profit of 30 ringgit. So 2 tables times 2, 3 tables times 3, 90 ringgit, and so on. So if we have X table, it has to be 30x ringgit. Similarly, Y, okay, 1 table, the profit is 10 ringgit, and 2 tables, 10 times 2, 3 tables, 3 chairs, 10 times 3, and Y chairs, 10 times Y. And the total profit is these two add together, 30x plus 10y. This is the total profit. Now, next we look at the working hours. Okay. Now the working hours, 1 chair needs 6 hours, 2 chairs, 2 times 6, 3 chairs, 3 times 6. Sorry, tables again. Sorry, I mix up chairs and tables. So the first line is, the first row is table. Okay. So 6x, it means 6 times x. So this is the total working hours for making tables. 1 table 6 hours, 2 tables 6 times 2, x tables 6 times x. For chairs, 1 chair is 3 hours, 2 chairs 3 times 2, 3 chairs 3 times 3, y chairs 3 times y. So these are the working hours for tables and chairs. The total number of working hours, 6x plus 3y. And the total, the limit for working hour is 40. So it has to be less than 40, cannot be more than 40. We look at the storage space. The storage space for table is x, then chair is 4y. Okay, next, the first inequality we can construct is for working hours. The total number of working hours must be less than 40. So this is the total working hours. It has to be less than 40. So 6x plus 3y less than or equal to 40. Okay, next, they say the number of chairs must be at least 3 times, right? 3 times the number of tables. So 3 times the number of tables, that is the number of chairs. And they say must be at least. So it can be bigger or more than this. It cannot be less than. It cannot be less than this. It must be at least 3 times. Okay, next. So another inequality is the number of tables must be less than 4. The number of tables must be less than 4. Okay, next. Okay, now using these inequalities here, 6x plus 3y less than 40, y is greater or equal to 3x, and x less than or equal to 4, we plot over here. Now this is the line y equals to 3x. Greater than 3x is referring to the region above the line. Now this is the line, this green line is 6x plus 3y equals to 40. So if you want to be less than 40, the region below this green line is the region less than 40. So all the points, oh, my mouse is jammed again. Now all the points bounded by the two green lines and the y-axis, okay, they satisfy the inequalities. Okay, they satisfy the inequalities. Okay, now each point in the region represent a pair of values. Okay, each point in the region here bounded by the two green lines and the y-axis represent a pair of values. Okay, so they are, let's say for example, the point here. Now these points here, they satisfy the inequalities, the two green line inequalities, and each point here, okay, represent a combination of chairs and tables. Let's say for example, if I take this point here, it is 1, 6. It represents one table and 6 chairs. Here, let's say here, this is 2, 7. It represents 2 tables and 7 chairs. So each point here represents a particular combination of chairs and tables that satisfy the inequality. Okay, so these two lines, y equals to 3x, 6x plus 3y is 40, and this area here satisfy the two inequalities. Okay, now we talk about the profit. The profit is 3x plus 10y. Okay, 3x plus 10y. Okay, so we have to maximize this profit, 3x plus 10y. So I have plotted this line 3x plus 10y. It is the blue line here. Okay, so I try to move this blue line, and you see the first point it hits is 0, 4, and then next point, I want the maximum value, so I want the last point that it hits is the maximum point. So can you see this point here? This point here is the last point. It will give the maximum value. See, the maximum value is around this. Okay, so the last point here, one more time, if I drag this line, okay, these are parallel lines. Okay, these are parallel. As I drag this blue line, the number here change. So I'm actually showing the value of the profit as I move higher and higher, the blue line higher and higher, and the last point will give the maximum value. So this is the last point. The last point is 2, 9. So I use this value 2, 9, and I substitute into this function here, and it will give me 150 ringgit. Now in this problem, you have to choose the whole number, because the number of table and number of chairs, they are whole number. That's why I'm taking this whole number points. Now in other problem, you may find if they are not whole number, then this point should be the maximum point. Okay, if you are facing other problem which x and y, they are not whole number, then you have to take this this point here, the point of intersection between the two green lines, because they are it is the maximum. But of course we don't produce 2.5 tables or 8 and 8 chairs. We don't produce this type of thing, cannot produce 2.5 tables, so we cannot use this point. So the next whole number is this, the highest whole number is this, it is 2 9. So we have to use 2 9, substitute into the function, the profit function, and you get the maximum profit 150. Now you take any other point, let's say this point or this point here, then the value is only 88 or 90, it's only 90, so the profit is only 90, around 90. It's 90, yeah, it's 90. Okay, you can see the answer here, right? So that's all. Good luck.